let's see, still, okay. Anybody need to go through these questions? Anybody? If not, then we'll just continue on. Okay, that was last week's stuff. So if anybody have any questions regarding these 4 questions, ask anybody in the Discord group, or send email. Again, my my email is robotics. One more time, okay? That's my email address. So, these are the kind of problems we're gonna, encounter, right? When we participate in the contest, So yeah, so throughout the class, we'll do all these questions from previous contests from previous years. Today we are actually going to go through a this is another type of problems that you will see in these contests, which is called "What does this program do?" What they do is usually they give you a simple program, but they can't really be any language specific, right? They can't test you in C, because not everybody knows C or Java or something like that. So what they do is they have this thing called pseudocode. Pseudocode is sort of usually it's kind of loosely defined as something that's logic that describes a program, right? But in this case, they actually defined they created a simple language. Okay, with this type of problems, so they give you they give you a program, right, written in this ACSL pseudocode, and then you, as the contestants, you're asked to read and understand the program, understand what it does, and then determine what it does, right? And usually they also give you some numbers, or they give you a program and then give you another set of numbers as inputs to the program, and then you're supposed to reach a conclusion or find a solution or find an answer. Right? It's in practical terms, right? In what I do, writing code at work, frequently you're basically required to be able to understand or use or modify other people's code, right? It's either a section of code, or somebody wrote a library and you're supposed to use it. And then sometimes people make mistakes, right? they create a library function and something like sorting or play a video file or anything like that. They can make mistakes in there, and then when you encounter a problem, the original person who wrote the code may or may not be around, right? The person could be, retired, could, moved on to another job, whatever. And so you will have to understand what the code does, right? Read the code, what they do, and sometimes you have to, modify it, right? Or there are also situations where the whole system changes, right? Like a lot of times, one program depends on another program, right? A library code depends on something else, and that something else changed, and you have to make changes to the library as well. So, like in all these situations where you basically have to read other people's code and understand it, and then you will be able to use it or modify it, right? Make changes to that, and in that process, not screwing things up. So this is where this type of ACSL questions map to a real world problem, right? When you become a software engineer, these are the things you will basically have to do. So this is basically that ACSL pseudocode, all in this one page. But again, I assure you that it's sort of loosely defined. Okay, so like the definition says, for example, here, if then else, and then you should have an end if. A lot of times they don't. So a lot of times you just have to kind of read the code and try to guess what their intentions are, really. So they actually have, again, this whole thing is online, right? If I quit this mode, they have this web page, wiki page. They have everything in here. I basically just make that into, this one page thing that for the class presentation. And so you can see that they define all these operators, right? These are operators. I mean, if like some of you have learned Java or C, right? These operators look familiar to you. And since we are going to use, or we will probably use more Python than Java or C. So I kind of later on I map these things into what corresponding Python stuff would look like. So and then there's functions and variables, right? These are, all programming languages define these things. Sequential statements, decision statement is basically if then else. And loop statements, array and string. So these are the common things we see in other languages, right? But they don't go into more complex stuff, right? Like objects, right? Like inheritance and all that type of things. So what I call it is that they try to give you a very simple programming language, right? And if you go to ACSL senior level, they actually have another level of programming, which is assembly language, which is actually more primitive, right? it's a different type of language that's getting closer to the machine hardware, right? In that at that level, you only have very primitive instruction sets to write your program. But then again, you most likely you don't really recreate or write everything, right? You don't always talk to the hardware directly. You again use other people's code, right? Use other people's functions, libraries, and all that type of stuff. But in the ACSL context, things are relatively simple. Okay, so these are operators, right? We list them down in here. Not, right? Not and or, these are logical operators, right? Not basically is not is basically to say I have a Boolean expression following this operator, right? And then you negate that result. So example is like if A equals to C or A equals to B or A equals to C, right? And then in Python, the not operator is basically not, the word not, right? That's what Python uses. And exponential in the pseudocode, it uses the what is that? The caret symbol or the upper arrow. But again, they use that kind of willy-nilly. Sometimes they use one, sometimes use another, I guess, depending on who's writing the test problem. And then in Python, it's the 2-star operator, right? That's the exponential. And basically here is if you write 2 to the power of 3, right? The result is 8. Division and multiplication, right? This is multiply and divide. That's the real division, which is to say in this ACL environment, if you do 5 divided by 2, for example, right, you get 2.5. Rather than if it's an integer division, then you get 2, right? That's the type of difference. But a lot of times, I think you'd probably have to read the program or read the description of that problem to really understand what they actually do in that program. This modulus is basically to get the remainder of a division, right? So 8% 3 equals to 2, right? That's the remainder of that division, right? So if you do 8 divided by 3, you get 2, right? And then you have 3 as the you get what you get 2, right? And then you get 2 as the remainder. Add, subtract. There's really no nothing special there. And these are the same in Python, right? So these operators are the same in Python. Greater than, less than, no less than or no greater than, not equal. I mean, these are similar in a lot of languages. And the and or, these are from C type of languages, right? You can this whole operator set that they define are very similar to what you see in C or Java, right? And JavaScript as well. So those are actually a family of languages that probably had some roots some relationship to the C language. And then in Python, these operators are basically written out as word, right? So not, and, or, that's what you use in Python. These are operators. Operators make up expressions, right? So in expressions, the elements in expressions are, either variables, right? These are the actually, I should say, the first thing is constants, right? So these are like 1, 10, and string, right? And things like that. These are called literals, right? Constants or literals. And then you have variables, right? Then you have these operators and functions. And so these things together makes up, expressions, right? And then these are expressions where you can see that the first one is basically variables plus constants plus, and operators that makes up a expression, right? So the result of an expression could be assigned to another variable, right? I know these things are probably boring, but again, like I told you, warned you in the first class, the ACSL stuff is kind of boring, but these are the problems that you will see in the ACSL contest, right? And then there is a literal string, right? Bananas, and then the third example is the function, right? A function call. So to get the length of the string A -1, and then that value assigns to J. So these are expressions, right? These are, there's not much to them, right? If you have learned any type of programming, you probably have learned these already. Any questions so far? Probably not. So sequential statements is actually, I don't know, literally anything in program are sequential, a sequence of instructions, right? Sequence of statements. So they're really, all sequential, you can say, right? In the ACSL pseudocode stuff, they probably, because you only have what, 30 minutes on with 5 questions, so you have like 6 minutes per problem. So you don't really have a whole lot of time to resolve a complex, complex programming problem, right? So what that means is you probably don't have, complex structures like functions and writing a function and do all those type of things. So, this is a simple way of saying that there are some of these simple statements, right? Like getting user input, writing expression, and then assign value to something, assignment, right? That's what we call it in computer language. And then output, right? So they don't have, very complex ways to do output. They just, output a variable. So you get a value displayed. And so when you have composite statements like if then else, right? Those, when you look at that as one statement, right? When you have composite statements, that whole thing is a is one statement. That you can look at it also as a sequential statement, right? Because in the whole context of the program, the whole thing is run sequentially. And then you have these if then else. I don't know, you want to call it the wiki definition has defined this end if as the end of the if statement, right, as a marker. Some programming language actually do that. Anybody know shell programming? No. Okay. So we have one here. So if you have used Linux, right, you can write a shell script. A shell script is what, that actually has all these things in there as well. That actually use endif, right? And in programs like Java and these things, Python does not have endif, right? Because Python use the what do you call it, alignments, right, or indentation as markers of the block of code, right? So if you have multiple statements that are indented the same way at the same level, and those statements are one block, right? So, but in the pseudocode, actually they define this, but then when they actually write their problems, sometimes they don't actually use that structure. For example, this thing, right? This problem right here. There's no endif anywhere. So sometimes you just have to read the problem and try to guess what they actually want you to do. But this is nothing special here, right? It's basically any programming language does if then else pretty much the same way, right? If then followed by if is usually followed by a Boolean expression, right? Sometimes in languages like C, Java, and these things, a non-zero value sometimes is equivalent to true, right? You have that, but that's not the case here, right? But is it strictly that way? But I don't know. Again, you have to, when you encounter these problems at in the context, you have to basically read what they want you to do. Right. This is a problem. This is a program copied out of that the wiki page. This is a simple section of code, right? What this does is, if we describe the problem, it's basically this paragraph, right? This bullet lines here. So when you have a person who work, let's say in a restaurant, right, at a McDonald's, if you work less, up to 40 hours, you get, let's say, $10. No, these days it's probably $15 an hour, right? Let's say $15 an hour, up to 40 hours, right? Then if you actually work more than 40 hours, right, up to 48 hours, you get 1.5 times your hourly rate, right? That's how the real world is, right? And then you work over 48 hours, you get double your hourly rate, right? So if you read this program, you can sort of see how it does that, right? It does not, always, figure out what exactly it does not give you the exact, expression to say with your hourly rate, with your weekly hours, what is the result, right? It has some of this decision statements inserted in here. So what it does is, if the hour is greater than 48 hours, right? If you exceed 48 hours, you get double the rate, right? The numbers that exceeds 48, right? So if you have more than 48 hours, let's say if you have worked 60 hours for whatever reason, then whatever hours you have exceeds 48, those hours you get double the rate, right? 2 times the hourly rate. And then after this, the program only needs to calculate for 48 hours, right? Because the hours beyond, exceeds 48 is already counted to the weekly salary, to the total. And then if you have not worked more than 48 hours, right, then your hours doesn't change after this if-then statement, right? So you come down here. So let's say if you worked 42 hours, then the 40 hours is regular rate, and that 2 hours would be 1.5, right? 1.5 of your hourly rate. So this is a a way to compute the total number of the total number of dollars you should get paid for that week, based on the number of hours you work and then the hourly rate, right? Again, this is any question about this program? Right. Okay. It's relatively easy to understand, right? So this basically says if you have worked more than 48 hours and those hours get double the rate, and then after 48, below 48, any hours above 40 will get 1.5, right? And then the rest gets your regular rate. These are the kind of problems that again you see when you do the contest, right? So and then they have this loop. They have 2 types of loop statements, right? One is they call this indefinite loop. It's a while statement, right? This you have I think Java and Python and C all have this. Again, some what language has end while? It's probably again in shell. But any other language, I haven't seen this. So or maybe in some older languages, I don't remember. And so in this, again, you have this basically gives you a structure to repeat a task, right? Repeat some block of statements. Usually this has something to do with array or a string, right? A string is actually an array of characters, so a lot of times. And then array is, you know, basically a series of the same type of stuff, right? In most languages, maybe not in Python and JavaScript, but in most languages, it's usually an array is a series of the same, you know, same type of stuff. In here, I think it's probably, I mean, usually it's a series of numbers, right? So with while statement, you basically have to depend on this Boolean expression to, you know, evaluate to false, right? To end this loop, right? And if it does not, then this becomes an infinite loop, right? Indefinite loop may or may not be infinite loop, but it can be, right? So again, when you do contest, you probably would have to, you know, read this code, and you know, this basically gives you two arrays, right? A and B, and then it's put the whole thing is the two arrays were merged, right, into C in a certain way, right? And then this the end of this problem is for you to find a number in a particular position in the C array. Right? These are the kind of again, I think it's kind of boring, but you know, it's usually not too difficult to resolve. You just have to, you know, understand when this end loop continues and when it, you know, finishes. Right. This one finishes when you encounter a negative number in the A array, right? Because what if A or negative or zero, right? If you have anything, if you have numbers that are, you know, positive in A, then this loop, this first while loop will just continue. All right. And then you can see that it always N and J, these are always, you know, incremented, right? So it's basically looping through that array in these two while statements. Another type of loop is definite loop. So for this, because the I guess the kind of structure in the ACSL, you know, pseudocode, these things usually have a definite number of times that it will loop, right? But usually in other languages, in like C, right, it depends on how this loop and how these, like the start and end, these could be expressions, right? They're not necessarily constants. Like in here, this first four statement, the start is an expression, right? Although the expression does not change itself, right? But let's say the end, this one, right? The second for statement. Let's say if A actually changes, right? Although in this program it does not. The string, let's say if the string actually changes, and the string changes in length, right? Is there a possibility for this statement to become, you know, infinite loop? There's still a possibility, right? So if you continue to add something to A, and then the length of A could be, growing up, right? Just increasing all the time. And then the second for loop could also be an infinite loop. Although usually it does not go that way, right? Because in this case, the A doesn't change. So the length of A minus 1 does not change. Also, it depends on how these expressions are evaluated, right? If they are evaluated dynamically, meaning that the for statement and the end expression is always evaluated when when it gets to that point, rather than some in some languages the start and end could be determined before the whole loop begins, right? So if the length of A is determined at that point, and then you only have a certain number of loops to go through, right? But if the expression is evaluated at the end of every loop, right, then it's still possible for this definite loop to become an infinite loop, right? It can continue forever and ever. But in these sample programs, these are usually quite simple. So in this case, right, for this program, can you tell what the first for loop does? Anyone want to tell me? The first for loop, right? For j equals those 3 lines, right? Anybody want to tell me what it does? These 3 lines here. Yeah.
I think it reverses A.
It basically,
Like takes A and then puts bananas backwards.
yeah, it starts at the end of A, right? And copy it into T. And it starts from the end, S, A, N, A, da, 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 all the way back to B, right? And put it into J, into T. Right, so it does a reverse copy of A. Also in this thing, the step increment is optional. When it has that, the default is 1, right? Like in this statement, from 0 to length minus 1. So, and then the second statement, the second loop is that, right? Counting the number of letters that are the same and in the same position in both strings. And so when you reverse the string, and this part actually is a, what do you call that thing? When you reverse it, it's the same, right? There's a special term in English for that, right?
Oh, parent zone or something?
Yeah, something like that, right? So it reverses this and put it into T, and then it goes from the beginning to the end, right? From 0 to the last character, and then compare if they are the same. If they are the same, count it. Right? The number, the n, the num variable start with 0. So at the end, the num variable contains the number of letters that are the same in these two strings at the same position, right? So that's what this little program does. And arrays, there's nothing really special about arrays in ACSL pseudo-code language. The only thing I guess is that it uses the parentheses for subscripts. I don't know why, but that's what they do. So you can do one-dimensional, two-dimensional arrays. And then I don't know why they would like this. Kind of confuses me, at least. You probably again have to read. So be careful when they say sometimes it could start with 0, sometimes it starts with 1. Right? That's a little bit confusing because I think we're probably more aware of arrays usually start at 0, right? That's what C does, that's what Java does, and that's what Python does as well. So yeah, I mean, these are the two special things about arrays in ACSL. And then they have strings. Strings are very much like Python strings, right? In here, in this description. You have the length function to define the number of, to find out the number of characters, basically the length of the string. And a string can be empty and the length would be 0. And then it starts with 0, right, as the first character. When I say they're very much like Python strings, if you have done anything in Python, right, this is what I mean, right? So if you have a string like with that value, :3 in the subscript means from 0 to 3, right? So you'll get 0, 1, 2, and stops at 3, right? So you get the first 3 letters from that string. That's what it means. And 4: means from the 4th position on, right, to the end of the string. Oh, no, actually this means it will ask for, I think that's different from Python. Python would mean that you will have from the 4th position on to the end of the string. That's Python. This is the same, right? This is from the from position 2 and count 6. 1, 2, 3, 4, 5, 6. Oh no, actually from 2 to 6. So 2, 3, 4, 5, 6. Yeah, that would be that. And then this would be, of course, just one character, right? If you say S1, then you get C, right? So this is slightly different from Python, but otherwise it's very much like Python. So yeah, there's nothing really special about the string stuff, and then you can do string add, which is concatenation, right? Putting 2 strings together. So like the program here, right? T equals T plus A J, meaning that T, whatever is in T, right? You start with an empty string and then add that character from the A string. So A starts from the end of A, right? Starts here. So T would start here and then here and then one at a time, right? One character at a time gets added to the end of the T string here. So this is basically the ACSL pseudocode language. It's a, like I say, a simple programming language, right? Not very difficult, but that's how they write their programs. We'll take a break from here. We'll be back at 8, and then yeah, we'll do a couple of their test problems when we come back. All right.
Hey, no. Wait, what is biology? Stop. Hold it. Actually, stop. Answers. No, that's not important. That's not. I wonder what that is. What? I don't. Why? Oh. It's gonna open. Or no. Oh, you said it. Wait, biology is earth
Multiplication.
It's like
Like on the previous slides.
Hey,
Both
no.
the multiplication and the division is called tree.
Oh, sorry. That was my mistake. Actually, that's where I copied the whole thing from division. It should just say multiplication, multiply and division, divide.
Okay.
I should say multiply. And then this is real. This is they call this real division. That's from the wiki. What I want to say is that sometimes it may or may not be real division means real number division. Like I explained, if you divide 5 by 2, in integer division, you get 2, right? That's if you have seen Python, how Python works. I think. So if you do 5 divided by 2, you get 2 points. That's what real division means. You get a real number rather than an integer.
I mean, if you like, if you specifically specify a variable that is an integer, and then preventing Python from like automatically saying,
Yeah, I forgot what language. There are languages where if you, let's say if you define an integer, right? And then I think in C probably it probably automatically do that for you. Because if you say I is an integer, right? Then if you do an I equals 5 divided by 2, you'll get 2 back. Or you get probably 3 back. it does an automatic round. You can probably, yeah, it probably is a logical, a programming logic error rather than something else. But, I did, I had an experience where actually, I have an integer value, right? An integer variable. Then in C, I call a function. That function returns a floating number, a real number. And then that in one situation where the function actually returns I forgot a 0 or -1 or some special value.
I'm not trying to.
Then when it got turned into integer, that becomes like 40 billion or something, right? And actually that caused the program to deduct 40, a huge sum of money from somebody's account. Then somebody printed some sheets of paper, and then the next time it comes around, his whole account was drained because of that cost. That's sometimes because you see the compiler will tell you there's a mismatch here, a type mismatch. They give you a warning, but it's not an error at compile time. At execution time, it doesn't generate an error either. But it's a logical error because it's not an overflow. It's just because both numbers are 32 bits. Right? In the machine, in the storage. So when the function returns a value, and the value gets stored in a 32-bit memory location, and then that number gets directly converted into an integer.
So was it like -1 converted to
Right. It's basically something like that. It becomes a huge integer. And so it's actually a very small number, right? In real number terms. It's a very small number. It could be 0, it could be something close to 0, right? Let's say if it's 0.00000001. It's a very small number. Let's say it's 1 cent or 100 of a cent. And then that real number, if it's not rounded, treated as a real number, but as an integer and directly converted into an integer, it becomes a huge integer number. And that's where the bug was introduced. Sorry, somebody was asking me a question. Might have some in the kitchen.
Yeah, exactly. We do it. No. Yes. Yes. See? This is my. This is my school. Dude, that's not what I'm saying. No. Why would you bring a PC to already tried all of them. Choose one. Oh, will he voice stuff in? Oh, yeah, I used to edit. No, it's
Well,
not.
you have a hotspot? Oh my God, you know, so Donald Duck used to be. Oh my God, oh my God. Oh my God,
Bro, what is that?
have you heard of JavaScript things? Funny JavaScript This is true. Right?
Answer it first. No,
I
remember.
This is so.
Because each, like,
I don't know what he's getting from that.
I have no Wi-Fi. What do you think the logical output of this is?
It's not logical anymore, is it? I don't know. Could be four.
What
Who's not, so if you just do two plus two. Yeah. It's just JavaScript has some weird I don't know what they call it. It's these kind of automatic yeah, type conversions that they do.
No.
It's, I'll try to help this. Oh, we should get started already.
If I get more than three wrong, I'm good. If I get less than wrong, what the?
Okay. Got started. Hey, guys, we have to get started. So that's all we have for this class. For the ACSL pseudo-code stuff. And then the question you guys will encounter would be things like this, right? So let's try this one. Let's do this one. Question number one, right? What does this program do? Let me make it a little bigger. Okay, so let's do question one here. What does this program do? Right, so this asks you what would the see it says print here, and the the actual definition says output, right? So, but you kind of understand what it means. Everybody done or? Okay, so what's the result? Huh? 14, 13, 13, 11. Okay. I didn't get it quite done yet. I made a mistake in the first one. I missed the first statement. So let me try this. Let's see. See, how do we do this? Okay, gotta stop sharing, I think. Stop share. Start video. Oh, I have to, gosh. Disable the background. Okay. And trim this. Okay. So here's what I did, right? So say A, B, C, D starts with these values, right? 1, 2, 3, 4, right? And so if we did the first, okay, how do we do that? So let's try to make this a little smaller. Let me do this. We do that. Okay. Okay, that seemed to work. The first statement is if A plus C equals to D, right? I mean, then see there's a bug right there. If A plus C should be equal to D, right? Then D is D minus 2. So A plus C in this case is 4, right? And it's the same value as D. So D gets D minus 2. So D gets changed to 2, right? Am I doing it right? And then the next one is if 2 times D plus 4 times A, 2D plus 4A is 9. Right? Or no, 8. 8. But still it's less than 0. Less than 10, I'm sorry. Less than 10, right? So A gets A plus 4. A gets 5. Right? So A gets 5. And the next one is A plus D. A plus D is 7. Right? And then 3B plus C is 9. And so that one, A plus B is not greater than 3C plus C, right? So nothing changes, right? And so the next one is if B is less than C, B is what? B is less than C, right? So now that causes C equals to B, meaning C equals to 2 now, right? So we got 5, 2, 2, 2. Right? That's it. Am I right so far? I think so. So the result is 11. Right? Yeah, I mean, this is the kind of problems you will see. Let's do another one. Oh, hold on. Where did that one go? Here, I think. Um, okay, here's another problem. What does this program do? Should be simple.
Line numbers or
Sorry, what?
to the left are those line numbers or
Yeah, yeah. Yes. Yeah, because it has a go-to statement here, right? Go-to is go-to, I guess, in this case is another way to do loop, but it's really a bad way to do it.
What does less than and greater?
Oh, that's not equal. See, I'm telling you that this ACL pseudocode is, a lot of willy-nilly in there, right? That's actually, that's not equal in not one language. In is it in C? No. That's not equal in something. I forgot, but it's not equal. Okay, anybody got the value?
Zero.
Anyone disagree? What do you got? You think it's one? Okay. Okay, but I think you guys are on the right track, but I didn't finish the whole thing either, but I think it is going to be zero. The reason is that here, it starts with these values, right? Starts here, and then you can see this is actually a loop, right? It loops until k gets to 8, right? Because every time the go-to statement goes back to 20, goes back to line 20. Okay. It goes back to line 20 and loops down to line 30. K gets incremented by 1, right? So it loops 8 times. I shouldn't say that, but the thing is, you can see that when it gets to that point, gets to line 40, right? With an even number, C is 0, right? And so if you loop back again, you can see that when it gets to line 40, right? And it's an even number, C is 0. Right. So it is always when, you know, when it comes down to that, I think you could probably, you know, see that pattern, right? So if you want to finish it, you can, you know, continue a few more steps. I think the value is probably 0. All right, we have 10 more minutes. Let's do another one. Okay. Okay, here's another. What does this program do problem? Number 1. Wait, it's quite similar, but again, it's looping with the same fashion, right? You okay? You know, I have a simple magic. To put your thumb right in the middle of your forehead and try to, you know, do that for 5 seconds. Okay, anyone done with this? Anyone has anything other than 10? Okay, so here's what that looks like. Why is it so blurred? Okay. So that's what we have to begin with, right? C, D, and X. X start with 20. And so so basically once you get to right, when the program starts, C is 0, when the loop starts, right? D is X minus 1 is 19. So basically we start with C is 0, D is 19, and X is 20, right? So that condition that if X divide by D, right, is this time I think we should refer to that real division definition, right? So this is a real X slash D. It means X divide by D, and then you get a real number, right? So, all the way here, when we have X divided by D, right, is 20 divided by 19 is 1 point something something, right? It's not exactly the integer of X divided by D, right? So you have to get down to when D is 10, right? Then the 2 division would get you the exact value, which is 2, right? 2.0 equals to integer 2. I guess that's what they want you to get to, right? And then at that point, it is equal, right? So you get to C equals to D, right? The D value gets to assign to C. And then at that point, C becomes 10. And it's not 0 anymore. It doesn't go back to line 30 anymore. And you reach the end of the program and you get 10. Cool. All right. Thank you very much. We're right on time today.